Pre-calculus, how to find the distance between 2 points in the Cartesian plane. In this tutorial, we will describe how to find the distance between 2 points in the Cartesian plane. For example, let us describe the following. So, in order to determine the distance between 2 points in the Cartesian plane, we must understand the distance formula. Based on the Pythagorean theorem, a right triangle with the sides of length x and y and a hypotenuse of r, the following equation is formed. X squared plus y squared equals r squared. So let's take a look here. We want to actually, let's kind of show that out. So we have a triangle here, and pretty much at this angle here is really represented with a box here that represents 90 degrees, and so that makes it form, this is a what they call a right triangle. Why? So we have the sides, like we mentioned, we have a side here, this is along the x-axis. So from one end of the triangle along the x-axis, this represents one side, and then also we have the vertical here, this represents the y, and so that's the distance there. And then we have the distance between A and B. This represents the hypotenuse. But we also, in some books and other publications, they represent it with the R. And so what that forms is basically we have the Pythagorean theorem. Let's spell it out. And what it says is that we take the square of the x's and plus the square of the y's, and it will equal the square of r. And this is what the equation will look like. It would be x squared plus y squared equals r squared. Alright, next we're going to show we have 2 points in the Cartesian plane. Right at the bottom, since we talked a little bit about right triangles, we have the notes about the Pythagorean theorem. It produces the formula or equation x squared plus y squared equals r squared. What we want to show, we're still in a position where we're trying to derive the distance formula. And so what we're going to show is we have 2 points in the plane. So 1 point we have the coordinates. So the first point we have subscripts 1 that represents x1, and we also have y1. So the subscripts being 1 that represents point 1. And then for the second point we have x subscript 2 and y subscript 2, and that represents point 2. So what we want to show is we're going to derive the distance formula, and by doing that we can just run a line through the 2 points, and what we will see is that, alright, so the goal here is we want to find the distance between point A and point B. That's what the distance formula will show or produce. So how do you get that? What we will see is that when we actually have 2 points in a Cartesian plane, that we can piggyback off the Pythagorean theorem. We can try to form a right angle. So let's see if we actually, let's see what happens when we form a right triangle. We'll go ahead and take this and alright, so what we did was, now we're pretty much describing exactly what we described previously about the Pythagorean theorem. We have 2 points, and as you can see, a right triangle was formed. So what are we going to do here? So what we have here, we have point A or point 1, and it has coordinates x1, y1. We also have the second point, which has coordinates x2, y2. So the distance formula, we want to think about distances. So let's look at the sides, because the Pythagorean theorem says when we got the x squared plus y squared plus equals r squared, so the x's here represents one side. So what we do is, it's really the distance when we look at the x's here. Let's try to draw this out. What we have, if we go and do this here, and from one end of this side to this end of the side, we have x's here, but there are differences. So we could take the absolute value of point x2, which comes from this point, and subtract x1, which comes from this point. And that represents the distance along the side. And then for the vertical side, the same thing. What we'll do is, let's draw this out. We know it's about this distance here. And let's go all the way out there. And what we have is, we want to take the absolute value starting with the second point, which is y2. And then we subtract, it's really the distance between B and A. We're subtracting y1 from y2. And of course, we still have r out here, and that represents the distance between A and B. So now we go back to the formula. We'll start and say that we have r squared. This is the same theorem or equation below, equals x squared plus y squared. And then if we start to form and plug in what we have here, the distances of the x is really this. So we take the absolute value of x squared, or x2 minus x1, and then square it. And don't forget, right here we have r squared plus the differences between the y's. So we have y2 minus y1, and you square that. And so what we have here, we're saying that r, if we take the square root of the two sides, would leave us with this equation. It's pretty much the same thing. Minus x1, and that's squared, plus y2 minus y1, and that's squared. And then to simplify it, we know that r represents the d, so it's d equals r. And let's simplify what's under the radical sign. And these are really just parentheses, and this represents the distance formula. So we got x2 minus x1, and that's squared, plus we have y2 minus y1, and that's also squared. And this is the distance formula. And this is what we wanted to show. Okay, let's apply the distance formula. Alright, for this example, previously we derived the distance formula. We came up with the distance will be the square root of x2 x2 minus x1 squared plus y2 minus y1 squared. And so that would produce the distance between 2 points. Well, let's test this out. Let's all right, so towards the right I have a couple of points. First point has coordinates 1, actually 4, 1, and the second point has coordinates 9, 3. And all we have to do is pretty much, a good way to look at this is, let's look at it this way here. So we have the points there. So this is the first point, so this is going to represent x1, y1, and since this is the second point here, it's going to represent x2 and y2, and all we have to do is plug in the values and it should work. Alright, so let's see what we have. Alright, so we square this out. Let's see. Alright, so it starts off with the parentheses. We say we want to take the value x2, so let's go get that value. It's in the second point, and that shows the value is 9. So 9 goes here, and then we subtract, and it says the next value that goes in there is x1. So we go over here to point 1. Our x1 is 4, so 4 goes here. Then we square it, and it says to add, and then we take the differences of the y. So first value is y2, which would be in the second point. Y2 in this case is the value 3, and it says subtract, and then we go and look for y1, which would be in point 1, and it shows that y1 here has a value 1, and then we square. Alright, so we'll keep computing. Alright, so the difference between 9 and 4 is 5, and that's squared. And then the difference between 3 and 1 is 2, and that's squared. And let's also keep the d out here because we want to be consistent. Alright, so now we have the distance equals what's under here. We can break it down further. We have 5 squares, 25, plus 2 squares, 4, and then we have d equals the square root of 29. That produces a value of d equals 5.385. And this is what we wanted to show. This puts us in a position for my next tutorial where we describe how to find the midpoint of a line segment. I hope this tutorial was helpful. If you find this tutorial to be helpful, please subscribe to my YouTube channel. Also feel free to join us here at the Computing Sector. There will be more videos and tutorials coming soon. Thanks.